Hi, today I will do my video assignment MAT 183, which is application of differentiation, and my group member is Aizat and me, Shamil and Fidai. So let's go to the introduction.
Okay, so what is differentiation? Differentiation is a mathematical concept used to find the rate at which a function changes at a particular point. It involves calculating the derivative of a function which represents its rate of change. Differentiation has various applications in fields like physics, engineering, and economics. It helps analyze rates of change, optimize functions, and solve real-world problems. By applying differentiation rules and techniques, we can determine important properties of functions such as maximum and minimum points, slope, and concavity. Overall, differentiation is a powerful tool in calculus that allows us to understand how functions behave and quantify their changes. Okay, now we move to the related rates. So what is related rates? Related rates refers to a branch of calculus that involves analyzing the relationships between the rates of change of different variables. It explores how changes in one quantity impact the rates of change of other related quantities. The goal is to determine how these rates are connected through differentiation and find specific rates of change based on given information and equations. Related rates find practical applications in various fields including physics, engineering, economics, and biology. Some common applications include analyzing motion in physics, studying fluid dynamics in engineering, modeling economic relationships, studying population dynamics in biology, and solving optimization problems.
For our first problem statement, Ali has a large storage tank in the shape of an inverted cone. He filled the tank with water at a constant rate of 8 cubic meters per minute. At some point, the cone has a height of 12 meters and a base radius of 6 meters. Ali suddenly wonders how fast the water level is rising when he remains filling up the water into the tank until the depth reaches 4 meters. Okay, let's get into our first problem solution. Based off the problem statement, the inverted cone has the height of 12 meters and a base radius of 6 meters. And the depth of water is 4 meters. And it gave us a constant rate of 8 cubic meters per minute. That is dV over dt. So the problem is we have to find the height of the depth of water when it reaches 4 meters. So we have to find the dH over dt. The first step is we have to find the radius of the water level. To find the radius of the water level, we have to use the application of similar triangle. Okay, so it will be R over H equal to 6 over 12, and if we simplify it, we will get R equal to H over 2. After we get the R equal to H over 2, we put it into the formula volume of cone. That is V equal to pi over 3 times R squared times H. And we will get V equal to pi H cubed over 12. We now just substitute H when H equal to 4. It will be dV over dt equal to pi over 4 h squared dh over dt, and then dV of dt is 8 equal to pi over 4. We substitute the 4 into the h, it will be 4 squared dh over dt. Then we move the pi over 4, the 4 into the 8, and we will be 32 equal to 16 pi dh over dt. Then if we simplify it more, it will become dh over dt equal to 62 over 60 pi. And the answer we will get is dh over dt equal to 2 over pi. Therefore, we conclude that the water level inside the cone is rising at the rate of 2/pi meters per minute.
So we go to problem statement 2, which is Sarah is hosting a party and wants to decorate her living rooms with balloons. She has a special helium tank that can inflate balloons at a constant rate of 10 cm³ per second. She decides to use sprinkle balloons and she wants to know how fast the radius of a balloon is increasing when it reaches a radius of 5 cm. So, how to solve it? As we know, its radius is 5 cm, so we use dv over dt equal to 10 cm³ per second. So, what is dr dt? As we know, volume of sphere is 4/3 pi r³, and we use dv over dt equal to 4/3 pi times 3 square r square, and we get 10 equal to 4 pi times 5 square times dr dt. After that, we can get 10 equal to 4 pi times 25 times dr dt. 10 equal to 100 pi times dr dt. So, dr over dt is 10 over 100 pi. After we simplify it, we can get dr over dt is 1/10 pi cm per second. Therefore, when the radius of the balloon is 5 cm, the rate at which the radius is increasing is approximately 1/10 pi cm per second.
In conclusion, related rates is one of the subtopics that enables us to predict when the specific things are going to change, regardless of whether it is increasing or decreasing. From this video, we can accurately count the difference in changes that happen by applying the chain rule and implicit method to solve the question. Lastly, we must understand that related rate also can be used in our daily life.